We have a lot of experience with waves. So like if you look out in the ocean, we see these waves coming in, okay? And if you throw a pebble into a pond, you see these ripples going out from where you threw it. And wind blowing over cornfields here in Indiana, that's great. You can see these ripples moving that look a lot like the waves in an ocean. So we see these quite often. We see waves quite often. And so when we start to try and think, how do we quantify them, think about their physics, a good question to ask is, what's moving? What's moving in a wave? If I think about throwing a ball, I have a ball and I throw it. It was here and the ball is then over here somewhere. The ball moved. But what's moving in a wave? Okay? So moving in a wave takes on two different forms. There's lots of things moving. If I look at a bubble on the ocean here, there's a bubble sitting there, I can see that that bubble is moving up and down and up and down as the wave passes through it. Okay? If you've ever seen buoys out on the ocean, they also move up and down and up and down as the waves pass by them. And so there's some motion happening there, but they're not really going anywhere like the ball. The ball was here, now it's over here. This bubble or the buoy never really travels any direction. So we separate things from displacement as describing the up and down motion, the repeated up and down motion of something that it's not traveling anywhere, just moving around some point. Okay? And we'll get into an equation that describes the displacement of something like that. And then we have traveling, or travel, and that's going just one direction. So I'll go this way to match my pictures up here. Traveling is something that was in one location and then ends up in another location. It doesn't necessarily come back and oscillate back and forth. It's moving away or moving towards something. And so in this case, the thing that's traveling is, well, it's the wave. So how do we describe that any better? I see a wave on an ocean come in towards the shore. Okay, this wave is out here and I watch it and it comes into shore. So what's really moving? Or traveling? The bubble is oscillating up and down, but it's not really going anywhere. It has a displacement, an oscillation there. But the wave is what's traveling. And what we actually can do to be more general than saying the wave is we can say the disturbance. Okay, the disturbance. The disturbance is what travels. And so this bubble is up at one point in time, and then it's down, and then it's up again. But if I were to look at a next second, a bubble right next to it would then be up and up. So it's the wave as it moves, the crests and valleys move, whatever material makes up the wave, you can predict what it's going to do based on what happened to a bit of material before it. So the material, if there's a bubble right here, as this wave's traveling in, I predict that that bubble is going to move up because this bubble was up before it. And then this bubble is going to go down because this bubble before it was down. So as that crest moves through, it's going to pull that bubble down. This one moves up and then comes down. And so it's this disturbance, these molecules, the material of the wave gets disturbed, and it's that shape of that disturbance that moves. So that's maybe not sound much better, but we're going to see how important that is, the difference between traveling, which is just a disturbance, versus a material travel, which like the ball is traveling, rather than the oscillation, the displacement away from equilibrium of the pieces of the wave.